Hello, yo, CSC, come listen to me. We're working on an assignment. It's called Beats by CSC, or Beats by Dr. Chi. We're gonna be working in C, and eventually you will write a program that links the beats. Okay, I'll stop there. Welcome to the live stream, where we will be talking about beats, CS beats, I think. It has had many different names at many different times during its development. One of those names was Beats by Dr. Chi, which is not the name we're going to use because it's a little bit silly compared to the other possible names that this could have. So, CS Beats at the moment. I actually only decided I was going to freestyle there about 30 seconds before I started, so it's not as polished as it could be, but you know. Okay, so today we are talking about CS Beats, and I do have a guest who I think has just joined the call here. Let's just give him a time to join up. There we go. There's Tom. Hey, Tom. Ooh, hang on. 1 second. Let me just set up the properties so that you can be heard.
That would be quite kind of you.
Okay, this should be better now. Your voice should be coming through now.
Hopefully. Hello, everyone.
Yep. Okay. I can see the little sliders moving. Just make sure, can everyone else hear Tom when he speaks there? I'll just wait a couple of seconds to see if anyone has... I don't know what our delay is on the stream at the moment.
I'm just about to join the stream now, so I can figure out what's going on too.
People are now saying they can hear. So I think
Perfect.
it's like that must mean we're on about a 10-15 second delay, which is fairly normal, so it's no big deal. So
Sounds about right.
Tom's here to help talk about CS Beats. Tom, you missed. I just did a freestyle rap. That was like fully freestyle, so I decided to do it like about 30 seconds before I started. So, as you know, as you may have seen, I mean, we can really like immediately start talking about what is the theme of this assignment, which is CS Beats. So I've got the assignment spec open here, and I've got a little overview set of notes here that we're going to go through. So it's not like a full-on lecture. It doesn't have like really specific things I'm talking about, but I thought we should cover these details at least during these 2 hours. Anyone who saw the first assignment live stream will be familiar with this idea that we go through what it is, how we're using it, and some of the details about, you know, how to do the stuff, how to get the marks. It's what most people are here for. So, Tom, someone just asked, when is the extension being released? Do you have an answer to that question?
I do have an answer to that question. The answer is, unfortunately, it's not going to be released today because there are still some lingering problems with it we need to fix. I'm happy to give a very brief sort of spoiler alert of what the extension will be, but we didn't want to release it until it was properly ready. Also, in any real world situation, things will come out in dribs and drabs, and you have to sort of, you know, think about it after the first moment. So we can justify this as being an example of the real world, rather than just the fact that it's a reasonable amount of work to get the extension stuff fully set up and ready. But it will be coming out tomorrow or the day after would be my guess.
Cool. Sorry for putting you on the spot. I thought it might be ready now, and so I was like, "Hey, is it?" But no.
Okay. It's not quite ready. I thought about having it ready, but I figured it would probably better to be sure that we're happy with it before you send it out.
You don't want as we've discussed even in the lectures before, you don't want your timeline coming from marketing, which is me. You want your timeline coming from when it is ready instead. So it'll be ready in the next day or two. So, things we're talking about. So, what is the theme of the assignment? So, I wrote a little intro here talking about digital music, in a sense, and how, you know, through the years of making music, especially when you get into the 1990s, and electronic music became like a really big thing. Making music with computers became a very, very much legitimate thing to do. Now to the point where people generally don't make music without computers. So nearly, I mean, you know, there's still plenty of people performing live and stuff like that. But even then, all recording's done on computers. So, computing has a very, very strong connection with the music industry. And so we themed this particular assignment on things like music production tools and stuff like that. So the idea is that in CS Beats, you have actual beats, which are nearly what we can think of as time steps. And we would go through those beats one at a time at specific times based on the speed of the music, what we call the tempo. And at each one of those points in time, certain notes would play. And we're using linked lists and pointers and memory allocation and stuff like that to represent which notes are going to happen at which times. So that is the idea. I think, I just realized something, because this was written a little while ago. I say, while we won't necessarily be making genuine music, Daft Punk is safe from our challenge to their supremacy. Daft Punk is no longer safe from our challenge to their supremacy, because Daft Punk have broken up and retired. It was only a few weeks ago. So I didn't actually edit this bit of the writing between when it was written originally and when Daft Punk broke up. But, may they not necessarily rest in peace, because they're still alive, but may they enjoy their retirement, and we will continue enjoying the music that they've made over the years. Someone said, as a music student, the 1 to 12 numerical notation brings you physical pain. You don't want the 12 chromatic notes. You'd prefer everything to be in tones and semitones instead. I mean, maybe an interesting thing, this is J-Man here in chat, an interesting thing that you could do is build your struct and a set of hash defines in a particular way so that your notes can be mapped to a very specific mode, if you want, rather than just the chromatic 12 notes of the kind of Western music scale that we're using. Not even scale, is it? What would we call it? I guess chromatic scale. It's been a long time since I've done anything theoretical musically. I don't know if you can tell I used to be a musician.
Might be worth jumping in here to say as well that while we designed all of our assignments so that hopefully there are some people who are really, really invested in, like, oh my goodness, this is cool, this is something I'm interested in. We've had assignments about like Pokemon before and painting, all this sort of stuff.
Yep.
If you aren't a musical person, that is totally okay. You could entirely ignore everything musical about this assignment and you would still be able to get full marks. It's just that if you are interested in music, we've added in a bunch of things that hopefully you find something extra in here that really you can sink your teeth into or that you really enjoy. But don't feel like if I don't understand music, I can't do this assignment. You absolutely can.
Yeah, there's definitely no prerequisite knowledge about music. It just happens to be the way that we've structured it to make it, I guess, more what would we call it, contextualized, in a sense, in that, like, if you think about an idea of a world that we're doing the programming in, this is an idea. But really what's happening is you will be working with linked lists, and you'll be working with inserting and removing things from linked lists and stuff like that. So the programming concepts that are going on here work with this idea that there's a beat. I wonder if I should talk about the track or just the beat first. Maybe I should talk about the beat first.
I talk about the beat first, yeah.
There's a beat. And the beat is going to be a struct. So it's going to be like the same way that we were doing things like memory allocated structs and things like that. But one of the pointers coming out of the beat is going to be a set of notes. I wonder if we should. I won't go. Actually, I was gonna open the code and go into that detail, but maybe I'll just keep going here about the just the theoretical idea of it first.
Can I suggest you can draw it out, but there's also a utility in the assignment that you can go to that will demonstrate this.
There's that little. Is it? It's in the assignment spec, right?
It's in the assignment at the end of stage 1.
Yes. Here we go. So we have the beat and the nodes. Is it called nodes?
Does it say node?
It says nodes, not notes.
Oh, it probably should say notes. That would be a.
But
Yes.
we can add notes, and the way that we're representing the notes is basically with two numbers. So they have an octave, which is going to be like sets of notes. You could, if you want to, you can think of this like numbers. You can think of the octaves as the tens and the key as the ones. We sort of just had to find a way to name this so that it was going to work. So if I have octave 4, key 5 or something, so that's just a note somewhere, I can add that note, and that will be the first note in the list of notes that beats points at. Maybe I'll draw this, because I've already started drawing it here. So you'd add notes here, and the end of the list will point at null. So what you end up with is just basically a linked list, but instead of having just a head pointer somewhere, we had another struct that was keeping track of where the first note in this thing is. And then that is the beat versus the notes idea. So there can be many notes there. I was trying to make it look like there's many notes there, but you know. So what we have is the first parts of the assignment are just working with this idea that you have a linked list of notes, and you have to be able to add notes to the list. You need to be able to loop through those notes and stuff like that. So when we think about it, these kind of core ideas of what's important to be able to do with linked lists is to be able to create a linked list and to be able to look at everything that's in it. I'm going to talk about the stages in more detail in a second, but the idea is what we're thinking about and what we're learning is going to be information on can you construct linked lists, can you allocate memory for them, can you keep track of them with pointers and things like that, can you use some pre-made structs that we've given you, and can you edit them and still have them useful once you've edited them and things like that. We are also going to answer questions today if anyone has questions. So as I'm talking through this stuff, or if I pass over to Tom to have him talk through stuff as well, let us know if there's anything that you want clarified or anything like that, because today's live stream is not structured in any way. So whether we fill the 2 hours with content or not is mostly going to be based on whether people have things that they want to know about. So let's have a quick look at the technical setup of this. Now that we've got a vague idea of what's going on, it only has to be vague at this point, is that you know that you've got a beat struct somewhere, and you have some notes, and you're going to be adding notes to a beat, and eventually if you go deeper into it, you'll also begin adding multiple beats to a track. So you're kind of going to end up with a two-dimensional linked list. I don't want to really call it a two-dimensional linked list because it's not really the way I like to think about it. Like, I've got one list which is going through time. The beats are all going to happen at a different time, and each beat has certain notes that are going to play at that time. So rather than thinking about it like we did with slide and the two-dimensional array, which is a space, and both dimensions are kind of similar kinds of things, this is very different in that you could technically think of it as a two-dimensional linked list, but what it really is a linked list of certain things, and each one of those contains a list, but it's a completely different concept. So it's more of like, I start to, the more we use structs, the more we start to like name them and think of them as actual concepts. So you've got a track that has multiple beats in it. Each beat has multiple notes that might be playing at that time, and then you go on like that. Okay, so talking a little bit about technical setup, there are instructions at the very beginning here that says this is how we set up what we need for the assignment. So I've got a fresh... Oh, actually, I'm in the middle of the reference solution here. I'll just quit out of this for the moment. So I've got a fresh folder here that I haven't done anything with. Actually, I don't think I even made the folder. So I'm going to go into my COMP1511 folder. How you organize your own home directory is up to you, but I personally would potentially want to keep all of my code for different subjects in different folders. That's pretty easy to do. So I've got this here, and you can see it's got stuff from before. So before I started programming in the live code folders, I think the very second lecture I did the program here. We did something on arrays, I can't remember what that was, and I had assignment 1 in here. So maybe I would then make a new directory for assignment 2, change into that directory. So now I'm in the assignment 2 directory, as you can see here. And then I would say, okay, I heard that there are some things that are going to copy stuff across. So there's here 1511 setup CS beats, so that's probably going to do the copy nicely for me. If I want to, I can copy the individual files like this. This is actually the same thing. The 1511 setup beats is going to do the same thing. So I'll run that now. And it's done. It's polite to us. You know how like a lot of things in Linux don't tell you what they're doing unless something goes wrong? This is being polite, and it's saying copy this file, and this is actually a different command. So CP is a command we know. We've used this before to move things around. Well, not move, but to copy things around. LN is actually linking. So one interesting thing that's happening with the assignment is you'll be editing one of these files, beats.c. You are not allowed to edit the main.c or the beats.h. So as I've been talking about in lectures, we're working with that kind of idea that the H file is an interface between two parts of a programming team, in a sense. So the other part of the programming team has written the main. They're like, you could nearly think of this as the front-end developers and the back-end developers. You're a back-end developer in this particular example, working on beats.c, and the front-end developer has been building this interface for a human to use to be able to work with our program. So between the two of you in beats.h, you have an agreement of what kind of functions are going to be called from the main, and you as the programmer working on beats.c has to provide those functions. So you have a copy of beats.c here, but main.c and beats.h are not actually files in your directory. They're links to files that we have. And the nice thing about that is if you try to edit one of those, it will probably tell you, it's like, no, you can't edit this, which is good, because if you think you should edit one of those, that means that there is an issue there between you and the other part of the programming team, and the decision's already been made about how beats.h is going to be. So in reality, in a normal programming environment, you might talk to them about it and say, are we sure that this function should be like this? But in this case, we've locked that one down because there's so many of you working on beats.c. We're not going to change beats.h unless something significant happens, and we need to change it. So if you ever feel like you need to change the main.c or the beats.h, there's usually going to be another way you're supposed to be doing this. You can think about it and then see if what you should be doing is in the beats.c file. If I do my ls here, because I've got the colors set up, I think 1511 colors is the command that will do that. Mine's already been done, so it's just like doubling up on it doesn't hurt mine. But you can do that, and then you'll see these have different colors. And in other times you'll see the directories are different colors as well. So beats.c is a file for you to edit. Beats.h and main.c are files for you to use. The nice thing about having these as links instead of files is you can, if something does go wrong, something drastically wrong with what we've set up for you to use, and we need to change one of those files, you won't have to think about it because your file will change automatically when we change it. It's unlikely that we're going to make any kind of major change to these files at this point. I always say unlikely because I'm a software professional, and intelligent software professionals never give you 100% on anything because we just know stuff breaks a lot. So I've done my setup here, and I've got these 3 files. So let's at least open these 3 files and have a quick look at what's in them. So the official name here, Beats by CSE, although I guess we could have called that CS Beats. And then we've got the main.c and the beats.h, and these two are really, really explicit about it. Do not change this file. So they're saying really explicitly that these files cannot be changed. The main.c has all of, if you look at the reference solution, which I'll talk about in a second, it has all this stuff that helps you run the program, and it has all these inputs and outputs, and it's handling them itself. You can quite possibly get away with doing this entire assignment without ever opening this file. You could run this file, you could compile and run this file completely on trust. You can just say, I trust that someone else wrote this file. I trust that that person understands what the front end is supposed to be on this thing, and I trust that it's going to work. I also trust that this thing is going to call the functions that I wrote, and then I will be able to see, based on what this thing does with the functions that I wrote, whether they're working or not. And that's why we've provided it. So there's heaps of this stuff in here, which, yes, you could have a look at if you want to. Check out input processing and stuff like that. You can kind of maybe learn something from the way that this is set up and stuff, but not necessary even to look at it. The one that you will need to look at, so Cameron's asking this, so we won't be adding any functions. You won't be adding any functions to the main. However, Tom, do you think that people will be editing the main for the extension?
No.
Yeah,
so
we're not going to go to that
there'll be
level.
a different main file for the extension, and you'll compile with a different main file and pretty much different every file, but you won't need to edit the main at all. It'll be the same exact thing.
Yeah, right. So even in the extension, the extension main will have more things in it, which will call your extension functions, but there won't necessarily be, what am I thinking? You won't be editing it. So
yes,
it'll be the same kind of setup where you'll be editing, the C file, and you'll be going sort of through the interface in a second. Oh, Anders said main.c fails 1511 style. That's very interesting. Oh, let's check it out. Let's see what we did. What have we got? No ZID in header. That's, I think, okay, because this is not made by someone with a ZID. I mean, it kind of is, because we've all got ZIDs at UNSW, but it's not officially credited to a single person. White space. Somewhere we have some white space things. We've got a line length going over 80.
Ooh.
Yeah, so there's a couple of things in here that might be interesting. White space. We've got a plus in there.
I mean, this was, of course, totally intentional because we were leaving it as an exercise to the reader to fix up the last bits of the style.
Sure.
And if anyone wants to send me an updated version of main.c with perfect style, feel free to. I don't know whether I'll update it at this point, but
there's a challenge. Should we give out an achievement for that? If someone wants to edit this so that it does have better style. I feel
like there's probably editing main.c is not the point of the assignment.
No.
If you can prove to me that you have done 100% everything, then maybe.
I see why we're going over the ends of the 80s. It's all this formatting stuff to make the user interface in the terminal.
Yes.
There's not much functional code that's going off the end of that. But when we're trying to do these big bars like this, it's going over the end. Oh, no, there's some code here where we could potentially make it neater. Anyway, let's not get too bogged down in that, but it's an interesting point. In terms of what you're going to need to read to understand the assignment, it's mostly going to be in this beats.h file. You'll note that if you read only the explanation of tasks in the assignment specification, there might actually be some ambiguity in here. There might be things where you're like, well, someone's written something and they've got an idea of what's going on and some theory and stuff like that, but I don't know exactly how this thing should work. It's because what we've done is we've started to push the documentation of how the functionality of the program should work into the places where people often put it when we're actually programming. So they're actually in here in the H file. So the H file will have function definitions here. Sorry, declarations, just saying, okay, there exists a function like this, and somewhere else is the code that actually makes this function run. But in here, look at this one. There's all these details, add node to the beat, the command A, which is going to be called in the main, and it's like, okay, all of these things have to happen. Here are some details, like exactly how it works, what values things are and stuff like that, and what you can use. And then the actual name of the function, which you will then be creating somewhere here in your beats.c file. So stage 1 functions, here's the one, add note to beat, that's the one I was looking for, same one as this one. And here we have put in what we would call a dummy implementation, which is just to say that, yeah, okay, this thing has the ability to work, but at the moment the only thing it's doing is saying this has not been implemented yet. And this is kind of a politeness thing that we've done, so that when you try to run things, instead of it just not working and you not being able to see what happens, this thing will specifically tell you, it's like, oh, you haven't implemented this function yet, and whatever command you happen to type in the interactive version has reached this function, and then it's run it and it's said, okay, this one's not implemented yet. So this is really similar to the way that we were putting these to-dos in that I showed you in lectures, which is just like, hey, remember that you're going to need to do something here. And so this thing is actually like programmatically, in a sense, reminding you, this isn't implemented yet, you will need to do something here. So each of the functions that's in beats.h is here in beats.c already. So this is actually a much more polite version of a C file than you would have if you were working in a team like that. Usually you'd get the H file and the C file would be your business. That is if you're the back-end person, or if you're the front-end person or something like this. A different file might be yours, and it'll be empty and you'll have to fill it out. But just to make things a little bit easier for you, we've made sure that the beats.c has a dummy version of all of the functions that need to be in the assignment in the 3 stages, right? So they're even separated with stage headings and stuff like that. So you can be like, okay, I'm going to go in here and do each of these things. And you note that there's not quite as much comments in here saying what's going on, but beats.h has all of the information, because we're expecting whoever's working on the main.c to look at the beats.h to say, okay, I need to call these things correctly. And whoever's working on the beats.c is also going to look at the beats.h to say, oh, I need to implement exactly how this works. So we've got some questions there. Cameron's asking, what would you say is the workload in comparison to assignment 1? Tom, what do you think? Do you think? I think we're looking at more, but not a huge amount more.
So my perspective on this is, I think that we've designed it so that it's a similar amount of work, but the difference is, I think that because there's more stuff going on at the same time, like you have to deal with while loops and with malloc and with strings and all this sort of stuff at the same time, that it's a little bit harder just because of that. So it shouldn't feel like more work in terms of the number of lines of code, I would imagine, but it may be that it feels harder just because there's more content that we're assessing in this assignment rather than the last one. Does that sound about right?
I'd agree with that. Yeah. We actually did look at that on just yesterday, that we looked at how many lines of code we wrote for a few basic linked list operations, but how much thinking that we had to do before we could write those lines of code. Like, we did an insertion into a linked list, and it's like, that's 2 lines of code. It's like, move one pointer, then move another pointer. Well, actually, it was more than that, but it was a very small number of lines of code. But it was some pictures, some theoretical thinking, and stuff like that. So you may find that the amount of hours you spend per line of code in this assignment will be higher than previously, but the amount of actual coding that you need to do is reasonably similar. Also depends on how up to date you are on the harder bits of the course that we've just been looking at.
Yeah.
And Cameron's also noticed here that, yes, it's another 10% weighting wise. And then for Cameron's saying that the assignment 1 was manageable for him at that point. But I think that this one, I would expect this one to take people a little bit longer, just because in general, I think that some people may have seen programming concepts before, or looked up programming concepts and stuff like that about working with arrays and loops and stuff like that, because that's really basic stuff. But when you get to manual memory allocation, memory addresses, linking up node-based structures and stuff like that, like linked lists, I think it takes more time to learn those. And I think that's the thing that might slow people down, is not necessarily doing the work on the assignment, but doing the work before the assignment to get a full understanding of it so that you can actually work on it.
On which subject also I would say this assignment is different in that there is more code that we're giving you. Like we're giving you beats.h and main.c. They don't necessarily make the assignment harder, but just the fact that there's a bit of code there that you already sort of have to read and understand what are each of the three structs, what are those .h files. If you're comfortable with those things, they don't provide that much extra work, but it's another one of those things that you will have to sort of play with, I guess. You'll have to deal with as you're going on. The other thing I'd say, and this is a more general comment, but one of the things that you will notice in computing is that we've pretty much reached the end of new syntax that we teach you in C. There's not a lot left in terms of like, oh, and by the way, there's this weird operator that does this thing. But there is a lot more of like, there is this idea now that we're going to talk about with, linked lists or with how memory is arranged, or all these sorts of things. So as we go on in computing, one of the things you'll notice is that there's more thinking with the same amount or less code. I find that's a trend that I've noticed, and you may even notice like during the course of this course as well. Now we're talking about linked lists. There's a lot more of like, it is 3 lines of code, but which 3 lines of code? Yeah. There's a great joke about, the guy walks into an office and says, why am I paying my engineers $100,000 to code? And they just copy it all off Stack Overflow. $1,000 of that is paying you to copy code off Stack Overflow, but $99,000 is knowing which code to copy off Stack Overflow.
Yeah, knowing whether the code you've just copied off Stack Overflow is actually relevant or will somehow interact nastily with the other systems that engineer has spent a lot of time learning about, and knowing whether it's going to cause problems or not. Srikar has a question there. M. Stefano was saying that they thought that stage 3 in CS Beats was roughly the same amount of work as stage 3 in Slide. I think I would probably agree in terms of the work on the assignment itself, but it depends how much work you've been putting in yourself to learn about pointers and memory allocation and linked lists and stuff. So I think some people might be waiting until I complete the Battle Royale example tomorrow in the lectures before they start on the assignment, because then you've got this kind of suite of capabilities that I've shown you that you can just pull from if you need. Shrika was saying, how come at the top of add note to beat they talk about printing the beat? Let's have a look at add note to beat. Is it in the H file? I don't see anything here. Maybe in the C file. Or did you mean the assignment spec? Let's have another look somewhere else for it. I mean, this could just be that we've made a mistake somewhere. Add note. The next one, scroll down. I'm not sure where I was at that point in time. This one? Print beat? Or
under the .h file, apparently.
In the .h file.
That's
print beat. This one. Under the function declaration. Yes. Okay. So the way that this is set up is actually the same way that we would set it up in a C file. Is we've got a function. In order to use that function, we put notes above it. So the comments are usually above our functions that explain the function. So this is the comment here that is about this function, add note to beat. And then there's another comment about the next function here called print beat. So at the point where we hit the semicolon here, everything about add note to beat that's in this file is done and finished and over. And then we move on to another concept, which is why we've got these big bars across here to say, okay, that one's over and now we're starting a new subject. And that is print beat, which is this next one here. So the layout... Oh, right, okay. Shrika's worked it out and is now laughing. You were reading it the other way around. Yeah, so the function in code here is not the heading. It's actually the final line of that section. So the comment comes first and then the code comes afterwards. The same way that we do it in, say, here in beats.c, where you go, okay, this is the explanation of the thing, and then the code comes afterwards. But I fully understand that, like, Yeah, that you think of it the other way, like the heading's the small bit, and then the big bit is the working code, and that's the way it's going to be in the C file. But in the H file, it's kind of flipped the other way around.
I'm going to butt in with a terrible example. Imagine, if you will, that Mark was going to be rapping, and right before he was rapping, he was going to get a big introduction. The comment is like the introduction that's like hyping up the rapping, and then the function prototype is the rapping itself. Don't know if that helps anyone, but that's sort of how I would think about it.
Had a little friend clawing at the back of my chair to get picked up, so she's come to say hi. Okay, so what was that analogy on the rapping is very popular. Okay, what were we talking about? We were going through the code. Let me grab my list of things that we're talking about. Okay, so we've got a setup. So we know we've copied the files, and we know kind of which files are our responsibility, which is the C file, and then the main file and the H file are things that we're going to use, but not necessarily edit. Alan's asking, when we free memory, do free the pointer to that memory. So every piece of memory we have, we know where it is. Well, hopefully we know where it is. If you know where it is, it means that you have a pointer to it, so you know its memory address. Store that memory address in a pointer somewhere. We free that pointer. When we call the function free on the pointer, it's going to follow that pointer into memory wherever it's aiming at, and it's going to free that chunk of memory. You don't have to do anything with the pointer after that, because the pointer itself is a normal variable, which will disappear when the curly brackets are closed. What I would suggest is, like, some people might get confused and start doing a memory allocation to memory allocate an actual pointer. I would say that that's generally not necessary. Generally, all of your pointers are not going to be heap variables, like memory allocated variables. They're just going to be normal variables that we're using. So each one of those is going to just keep track of where a piece of memory is, and when we call free, it goes to that piece of memory and it gives it back to the computer. Okay. So we've got our setup. So before anyone starts, they should have these 3 files in a folder somewhere, like this assignment 2 folder that I've created under my COMP1511 folder, and I'm pretty much ready to start working now. I can start editing things in this assignment, and I've got my other files here that I can read if I need. The other thing that we have, in case anyone wants to look at it, if you have, if you want to know what you need to implement, there's heaps of information here in beats.h. There's also information in the actual assignment here with some pictures and stuff. So we can think of it as being, there's many different ways of learning how this program should work. You can read the pictures, look at the pictures and you can go, okay, I have a theoretical idea of what's going on. You can read the H file and say, okay, I have the specifics of what's going on. But a lot of people might be in a situation where they're like, can I see this running? Can I see what it does? And then I'll write my code with a better understanding because I've seen what it does. And we can do that with the... actually, I should go to the assignment spec and show you where it is. It's near the top, the reference solution. So we've got supplied code. Here was the copy commands we're looking at. The reference implementation is 1511 csbeats_ref. I think that both of these do the same thing, don't they, Tom? Or is it only this one?
I think that the csbeats one without the ref may be incorrect. I'll have to double check. I can double check now.
Oh no, it's not that one. Yeah, that's a typo. At least
right,
the second line there has the correct one. So here is the csbeats reference implementation, or reference solution, as you want to call it, whatever you want to call it, is something that is a completed version of this assignment that... did you write this one, Tom?
I think I did.
I think you wrote this one.
I think I wrote part of it, at least. Yeah, I probably did, actually. Yes, I did.
Yeah.
It was a while ago.
So basically... Tom went in and solved the assignment. I mean, he wrote most of the questions in the assignment, so he was already ready to solve this. And so he's written a complete solution to the assignment, but not just a complete solution, one which also has some information in it that says, okay, these are the things we may be testing, these are the things we might not be testing, just in case you run into weird ambiguous cases for input and stuff like that, or certain categories of incorrect input. So some types of incorrect input where we're very specifically going to want you to check for them, but other things not necessarily. So I think that one of the things is we're never going to be putting in random instructions that don't make any sense. So we're only expecting you to deal with reasonably well-formed instructions. Shrikhar's asking, why is the E in beats uppercase? Is that an inside joke or something? Well, it's sort of an inside joke, but it's an inside joke to all of you as well, because see the capital letters? C, S, E? That happens to be the name of the school that we're studying at the moment, the School of Computer Science and Engineering at UNSW. So CSE, how we like to refer to ourselves, is kind of hidden in the title for CS Beats, like that. Yeah. So it is an inside joke, but it's an inside joke that hopefully everyone in the course can look at that and go,
Mark, can you switch to my camera for a second, please?
Yeah. Oh, hang on. Where are we?
It's an inside joke because I'm inside CSE right now.
There you go. There you go.
Sorry.
Yes. Okay. Let's move on from that. Okay. So with this reference solution, we can do a lot of the things that you will have to write code to do eventually. So if I start off with a question mark as the easiest thing, it says, here are all of the commands that can be given, and they're separated in stages as well, which is good so that you can see which ones you're currently working on. So we have our current beat, and this will always be tracked here by saying there's a beat being constructed, and there will always be one of the beats that's selected. Usually at the beginning there's only one beat. We don't have to worry about multiple beats until we get to stage 2 anyway. But first thing we can do is add notes to the beat, and so that's A, and it says octave number then note number. So A, I don't know, 5-5. Added note successfully, and now it's going to tell me the beat that's currently being constructed has the note 5-5 in it. I could add another note to that, 6-7, and it's saying, okay, so there's a previous note 5-5, the next note 6-7. So what we're getting is a linked list being built in the background. I don't even really need to know that that's a linked list. All I know when I'm using this is my beat has 2 different notes in it, and the notes have certain numbers which represent what actual musical note that these things actually end up being. And if I want to, I can print the beat that's being constructed. This is actually going to happen here automatically every time, but if you want to specifically test your print function, you can type in P and it'll say, yep, I've printed out pretty much the same line. It is counting up the commands I'm giving it, basically. So this is the 5th command I've given it. And we can do things like count the number of notes in the beat, so that, count the number of notes that are within a certain octave. So I've got octave 5, there's one note here, octave 6, there's one note here. Let me just add one more to this. So I've got one beat in octave 5 and 2 beats in octave 6. And if I then count how many are in octave 5, it says there is one note in octave 5. We just have sort of generic text here rather than changing it for whether there's a singular or a plural or anything. So it may not read 100% perfectly, but at least you're just going to get the same consistent output. Okay, and I could count how many beats are in octave 6, and it'll say there are 2 notes in octave 6 there. So that's our stage 1, and you can see in the background what's going to have to happen here is you're going to need to add notes to the beat that's currently being constructed. So there's a struct beat somewhere that has a pointer to a linked list of notes, and then you have to be able to add notes to that beat. You also have to be able to count how many things in this list meet a certain criteria. So that's like, like a really standard thing, and we've done a lot of that stuff with arrays before, which is just go through the entire set of information and then see how many things match a certain thing. So we've done I'm trying to think of all the lab exercises we've done. Like, I think we did we do a count even or a count odd or something like that in array? We may have done things like how many of these numbers are multiples of 3s and 5s. I think that may have been even before arrays, but something that we're trying to do a lot in computing is to look at a big chunk of data. Here it's not that big yet, but it could be, and say how much of this stuff is important to us in a certain way. Yeah. Cameron's asking, is there a reason we count the number of commands? I think, Tom, if you remember, I think the only reason why we have a number at the start of each line here is for auto marking, right? Or is it just
it's just for convenience. It's just literally just so you can know what command you're up to. I don't think there was a particularly good reason other than like it looked good and it seemed like a reasonable idea.
Yeah, I thought it might have been that we were piping that into auto marking so that if someone skipped a command or something like that, then we'd know where they were up to in their code. But we don't even need that, do we?
We wouldn't really need it, I suppose. Yes, let's go with that being an excellent reason why we did that.
I'm just making up reasons why. It's a reason why it might be useful. Otherwise, it's just easy for you to see where you're up to in your current test run if you're doing testing. Okay, so that's stage 1. I'm not going to go too deep into the other stages, actually, because I think that's the one that people are going to be working on first. It's also the one that's worth the most marks because it has the real core knowledge that we need you to do. Everything after that is just adding on, learning more stuff about similar things. Once we start, bumping it up from a single linked list to a list of linked lists, things get a little bit more complicated. Okay, so the reference solution, while you're working on things, you can be in the middle of say I'm here and I want to print the whole track beat by beat. Then I can say print, but I mean at the moment I've only got one beat, but when I want to see exactly what these functions are supposed to do and what kind of output they're supposed to have, then I can come back to this reference solution and say, okay, here. And this is especially something useful when you're deep in here somewhere and you're like, okay, so there's these details and there's these details and these details, and you hop back across to this file, you start coding it, and you forget some of them. And you're like, oh, what was the exact thing that I was doing there? And you're not 100% sure, and you go, I'll just run it against a reference solution. So I've got one window with the reference solution running and one window with mine running. Run them the same commands on both and go, oh, why is mine missing a note here? And you go, all right, something in that function that I wrote is missing that. So it's really just a kind of something that makes it really, really polite to be implementing this when you always know what you're working with, in a sense. Don't get too used to it though. In a professional setting, if I had a program that already did everything I needed it to do, I wouldn't need to pay someone to write another copy of the same program. So this is something that's very, very useful to us here when we're learning about things, because when you're learning about things, this is like an old school painting thing that people used to just repaint paintings that other people had already done. So you would paint your version of the Mona Lisa, and then you'd paint 20 copies of the Mona Lisa until yours got close enough to be something that you considered to be good enough. But then when you go to make your own masterpiece, obviously there is no subject, there's no painting that someone else has already done that you're copying. By then you get to a point where you're making it yourself. So at this point you can copy Tom's Mona Lisa here, which is CS Beats here, and then you can make yours work exactly like his, following the great masters of the art, and then you move on and eventually write your own programs. Tom doesn't know that. Yeah, I just put you on screen, Tom, to be like, sorry, copy Tom's masterpiece. Yes.
Yes,
okay.
I would note. I was going to make a point. I wasn't sure when I'd come on screen because my vision is slightly delayed. Even there are actually situations in industry where you would be copying an existing reference implementation. So there's things like if there is a piece of code that you are trying to imitate so you can test against your own code, then you would absolutely write a similarly working piece of program. If you had access to an old program whose behavior you wanted to implement in a new language or in a new platform, that's the sort of thing that would happen. So I just don't want it to seem like we've entirely pulled this out of nowhere. It's certainly not the most common thing.
We just don't do it all, yeah. There's actually
it's certainly not going to be your day job, but
yeah, it's interesting because there are a bunch of things that are super reliable programs running in banks that are actually running on sort of 20, 30-year-old code and hardware, or even older than that. Like
I heard a story once about so their computers built in the 1960s. If you go downstairs in CSE, there's an IBM 360, which was for what some of the banking programs were written. And it turns out that they found that some of these programs were still working in 2000 when Y2K happened. And if you don't know about Y2K, have a Google. It's an interesting phenomenon. But yes, there's some very old software running.
Yeah. Who knows? Some of you might be people who end up working in the future to say, okay, let's write modern software which is as reliable as this older software but runs much faster on modern hardware. It's actually a very difficult job, because when this stuff has been running for so many years and people trust it so much, you really actually have to make something that is completely bug-free before someone will accept the switch from one to the other. And that's very, very hard to do, as we probably have seen in your own coding.
I always like to point out the things that you can do after you leave 1511, much as we love 1511. There is a whole series of courses on writing software that is verified to be correct, and an entire profession around writing that sort of software. And if you go back, I think I mentioned this in the last assignment live stream.
Maybe.
Carol Morgan did a series of lectures on how to write good comments. But it turns out that his day job is doing those comments, except with actual proof systems that mathematically prove that your code is correct. So there's a whole bunch of stuff you can do there.
Yeah, I think that's always really interesting that we're thinking about making our code correct before we write it, rather than making our code correct during or after we write it.
Yep.
And I think that's a very, very good attitude to think about. So a lot of the stuff with this assignment, I would nearly suggest that you want to know exactly what your assignment's going to do on a whiteboard or a couple of sheets of paper or on Microsoft Paint like I do and stuff like that, and then you go in and code it, and then you refer to your diagrams with your code and say, is the code actually doing what the diagram said it was supposed to do? Because it's much easier for you to tell whether the sequence of commands is correct in the diagram than it is when you're looking at, reassigning values to pointers and things, and you're saying, okay, reassigning value to the pointer meant this thing now aims at this thing and stuff. Whereas it's like, this arrow moves from here to here, you're like, oh, that's much easier to see. So I suggest for this assignment, even the last assignment probably would have been useful, but this assignment much more so, is that pictures are really going to help you develop this rather than just diving into code. Okay,
on the note about correctness, I'd very briefly also say correctness is not just a property of your program, it's also a property of your style. Don't just think you can leave your style until the last moment as well. You should make it so that your program is always stylistically correct, rather than just like you end up with a mess at the end that you clean up, because it's much easier to keep your program having good style than the other way around.
There's a question there, good question from Ryan, saying, when are we getting our feedback for assignment 1, by the way? So,
yes.
Where are we up to at the moment? We've done some of the auto marking pass already, haven't we?
The auto marking is done, but not released to students, because we have to, first of all, so what happens is that auto marking is run, but then the tutors look at the auto marking to make sure that it's sane, and then they also do style marking. So the answer to your question is you will start getting feedback over the weekend, I would imagine. And the plan will be that all of the feedback, apart from for people with special circumstances like special considerations, those sorts of things, apart from those people, you should get your feedback by late next week. We'll try and give enough time to so you can apply that feedback to assignment 2.
Okay, so my list of things we were talking about. We've talked about the setup, the reference solution. We've talked about what's in the files. I should have put them in a different order, but that's okay. Now let's have a look at what we're actually going to do in the assignment. So here we go into the tasks. We've separated this into 3 stages. We also decided to add this time a a little bit of information as like a kind of a message from us as your teachers, why this stage exists and what it can be used for, in a sense. So we thought that might come in handy, where it's like, what skills are you learning here? How many marks is this part worth? And things like that. So it's kind of like stage 1 gets you to a passing mark, depending on your style mark, obviously. And stage 2 pushes you more towards, I think, a credit. And then stage 3 towards a distinction. And then if you want to go for the super high bits, the extension will be coming out soon. So I've already talked a little bit about what's in stage 1. It's all going to be working on one linked list in stage 1, and this is going to be a linked list of notes that are attached to a struct, which is the beat, which is technically another linked list, but for stage 1 you don't have to worry about the fact that the beat is a linked list. Got a couple of questions coming in here. Eric is asking, for stage 1, do we add the new notes to the start of the list or the end of the list such that the new note points towards null? Let's have a quick look at add note and see if that answers our question for us. Struct beat, it's giving us some information about these. Add note. Description, add a note to a beat that is being constructed by the main function. The new note has a specified octave and note. Got to get my reading and pronunciation going. When you run the command, beats.c, this function is called. Here is all of the details that has been copied from the H file into the assignment spec. And I see something here. The new note should be added to the end of the beats list of notes. This means that you should add the note directly after the note that was added the last time add note to beat was called. So we have been given, with no uncertain terms, a detailed idea of what is actually going to happen there. So every time you add a note, it is the last note in the beat, and it will be the end of the list. So every time you add a note, it's going to be pointing at null, and the last note that was there is going to be pointing at it. And then you go on, the next note you add after that is attached to the end of that previous note that was added, and so on. So if you look at what I did in the reference solution here, I added the 5, 5, and then when I added 6, 7, it went after the 5, 5. I added 6, 10, it went after the 6, 7. So the order of everything is going to kind of be maintained, and any new notes go on the end. You may note that is, I think, the only way of adding to a linked list that I did not show you in the lectures. So I showed you how to add one at the beginning. I showed you how to insert one arbitrarily somewhere in the list, but I did not specifically show you a simple way to add one to the very end of the list. So that's why it's in the assignment. It's like, can you, from learning the ways that I was teaching things of manipulating the linked lists, now do something different? It might even be a lab exercise, though, so it might be something where you can actually look at the lab exercise, get some practice there, and go, okay, I'm going to use my code here in my assignment, that kind of thing. Yeah, so there's that. Cameron's asking, will the extensions have a similar test-it-yourself vibe?
Do we want to come back to that in order, or do you want?
We're going to talk about extensions, but I'm going to say yes, but we'll talk about it in more detail in a second. Because I think we're nearly up to that point even here, because it was like stages, what's in the core, and then what's in the extension. So each of the stages will have enough information for you to do everything. Whether that information is all collected together in the H file notes, or whether you want to look at the diagrams to see exactly how it's working, or you want to compare it against the reference solution to see how you can make yours behave the same as it. Lots of options for how you want to develop this. I would suggest to skim the assignment spec first before going into either the reference solution or what's in the H file, just because what's in the assignment spec is the overview of what it ought to be doing, and so it'll give you the idea of what it should be doing before it gives you the specifics. So what I would usually do is I would say, okay, there's a box here that says this is the command. Here's a one-line description of that command. It's not going to be enough yet, but the one-line description will set the context for you that you can then develop other things. So we've got 3 stages here, as we had in the first assignment, and then we're going to have extension as well. So stage 1 is adding a note, counting how many notes are in the octave, and then... Oh wait, no, I've gone to stage 2. I was like, why are we adding beats? I know there was a third thing in stage 1. It was adding notes, and was it only 2? Adding notes and counting the octave? Oh, and printing out, but I'm not sure if we do the printing out. I know that there's another function for printing out, but I'm not sure if we... Oh no, there it is. Yeah.
There is another function,
because they were both in the same part of the stage. So there's a function for adding a note to a beat. I knew there were 3 things, but there's only 2 topic headings here. So there's adding a note to a beat, printing out the entire beat, and counting how many notes are in an octave. So those are like the 3 functions you have to do for stage 1. Stage 2 is where it bumps up the complexity of the linked list to say that we don't just have one beat. Any kind of music track that we might make is highly likely to have multiple beats in it, and each beat is going to have its own notes, and we're going to call that a track. The track is going to have multiple beats in it. So we're expanding our linked list now to not just be a single linked list of notes, but a linked list of beats, and each beat has a linked list of notes in it. So it just sort of ups the dimension, which ups the complexity of what's going on here. But when you think about it, if you can be kind of careful in the way that you're phrasing this in your head and using it, it might not be that much more difficult, you know? Because if you can already do things like add things to linked lists with notes, you should also be able to add elements to linked lists in beats as well as notes. The only thing that gets weird is that, you know, each beat has its own list of notes, and you just got to make sure you keep track of those things. But otherwise, this is why these commands are so similar. Lowercase a works with the notes, uppercase a works with the beats. Then we have the idea of tracking which one of these is selected. So we can have, in our track struct here, we might have even, like it's even like a really big hint here. We may have something in here tracking which of these beats is the current beat. I'm not going to say anything more about it because I might end up implementing it for you there. I won't go too deep into the stages, but yeah, stage 2 is about manipulating beats in tracks. And then when we get to stage 3, we want to make sure that you can do all of your memory management properly. So stage 3 is all about removing allocated memory and making sure it's removed correctly. Because we get to the situation where if we want to remove a beat from a track, we have to make sure that we're doing the correct removal code from a linked list. I haven't even shown you this yet. This is tomorrow in lectures. But also, when we remove something, are we cleaning up all its memory properly? So that we need to go back and look at everything that we've created and say, which parts of this data are memory allocated pieces and which parts of this data are not memory allocated, just normal variables. Normal variables get cleaned up on their own by the curly brackets, basically. But any memory allocated stuff we have to free explicitly. So you need to look back over how you've created things when you've added beats and you've added notes, and then say, okay, everything that I've added must be removed. I need to remove these things. I need to be careful about the order that I remove these things, because if I remove something that has a whole lot of pointers to other allocated memory, I'm going to lose the knowledge of where that memory is, and then I might lose the capability to free it. So a lot of this stuff will be you maybe even drawing those diagrams again of saying, okay, these are all the things that are memory allocated, and this is how I need to go through and remove that memory. Cameron's there saying leak check would help with this, definitely. So if you have a partial solution where you think you've freed up parts of the memory, you can run DCC leak check to tell you which pieces of memory you haven't freed at the end. So which pieces of memory were still floating around in your program. Okay, so that is the core of the assignment. But there's also a question here. What's in the extension, Tom? Should I throw across to you for this one?
Yeah, sure, why not? I should also probably be unmuted. So in the extension, there are 2 stages to the extension. It will look basically the same as assignment 1's extension, in that you'll have to do the same 3 things. You'll have to complete a task, You will have to write 2 tests for both of those tasks, and you will also have to write a short description of what exactly it was that you did to create those tasks. With the extension, this is all stuff where it's not in the spec yet, but just so you know what will happen, hopefully by the end of the week, you will have the spec. Should happen today, tomorrow is my hope. You'll have the spec and you'll be able to read through it. But basically, you will be given some extra files. The files will look very similar to beats.h and main.h, except they'll be the extension versions of those files. And there'll be a few extra functions that we give you, and also a few extra functions that we ask you to complete. Please make sure that you are submitting the extension version of those files, not the regular version. It should be even easier than last time because there's no copying involved. You'll actually have to grab a new file. So the beat.c stubs, there were some stubs left in there from an old assignment. Those aren't the extension stubs, so you can just get rid of them. And if you re-download beats.c now, you'll note that those aren't there anymore. Well, they shouldn't be. They got left in when they weren't supposed to be. Yes, that was a bit of an oopsie on my part. I thought I'd remove them, but I hadn't. This is what happens in coding all the time. You accidentally leave something in, or you accidentally take something out when you shouldn't. So those aren't the extension activities, to be clear. So I will talk very briefly about what the extension activities are, I guess. The first extension activity involves manipulating a linked list to do interesting things involving merging. So merging 2 beats together, or possibly more than 2 beats, and there'll be some specifics around exactly how that's supposed to work, and you'll have to look at the reference solution to figure out exactly what's going on. The second extension will be around saving and restoring, and so we'll give you some functions that will help you with that, and your job will be to be able to save the current state of your track and then restore it again. I'm being vague here because I don't want to talk about the specifics until the specifics are in the reference solutions. The one other thing which I'll say, though, in a slight difference to assignment 1, is that for the first extension, which is the merging extension, it'll be interesting because one of the tests that you have to write has an additional restriction. The restriction will be incredibly clear. The auto tests will tell you whether or not you've followed it. It's basically that for half of the marks of that extension, there is like an easier subset of the problem that you can do. So if you're thinking, I want to dip my toes into the extension, it seems cool, but I don't really want to do like all the work, there's sort of a partial mark that you can get that will get you up to, effectively, it would be an HD in the assignment if everything works out correctly, and you can do that sort of first part. And then the hope would be, well, if you've done the first part, it actually makes the second sort of little bit of it easier. So that's sort of the other thing that you can note. But apart from that, it'll be basically the same as assignment 1 was. It'll be the same thing around you test against each other's code, and you'll get marked on that. You'll get the marks, just as a side note, for assignment 1, that like competitive marking, that should also come out at the end of the week or so, or early next week. We're just running those tests now. As you can imagine, running 600 tests against 300 submissions, if you do a multiplication on those, you get a very large number. There's a question in there about, are you allowed to give us hints number-wise maybe about how many things we would be missing if we implement without considering the reference? You will not be able to implement without considering the reference. It's just not possible because like you will not understand the basic.
Cameron's question there is specifically about the extension.
Probably a good thing to clarify.
I expect it is, because I think if you're not asking about the extension, it's really clear in the spec what's going on, whereas the extension won't have 100% clarity in the spec, and you have to use the reference a little bit at least.
Yeah, so I mean, so for this one particularly, you will not be able to implement the extension without playing with the reference solution, because we're not going to give you even a full description of what the behavior of the reference solution is.
So what you can do if you want to think about this is that what we're trying to teach you is how to test code that you haven't even written yourself. So it's like, if you want to know what the code is doing and what it ought to be doing, can you figure out all the different inputs and outputs you're going to give it so that you can actually see if it's working or how it works? And that's you can already guess that's a really, really valuable programming skill, because we're going to be using that to help our friends out with code when we're working with other people. And also, we want to have a good amount of experience with writing tests so that when there's no auto tests, because auto tests aren't magically going to be there for every piece of code you ever write in the future. When they don't exist, you know how to write your own tests because you've had some practice with them.
Yep. And as well, I mean, like, this is, if you're wondering what your tutors are doing when they sit down next to you and they're looking at your code, what we're doing is we're thinking about what case is breaking this code, or what is it about this code that's different from what we're expecting. So it's actually a quite good experience in terms of like what we're doing, to be thinking about what is this sample solution doing, why is it behaving in a way that I expect or I don't expect, all those sorts of questions. So with the sample solution, I don't want to give a number on how many interesting interactions there are, because it's just very hard to do that because I don't even know how you count that. For the merging, there'll certainly be some things where you'll need to think about edge cases. For saving and restoring as well, in a slightly different way, but it'll be the same vibe of like there will be things you need to think about.
There's another question here about, will we get our marks for assignment 2 before the finals? No, you won't. So when you think about it, the final exam is 5 days after the... Is it 5 or even less? 4 or 5 days after the assignment deadline.
So assignments due on Friday are...
it's due on Friday, so it's actually 6 days.
It's 8 days.
Unfortunately, we can't turn around the marks for everyone in 6 days. So if we can't turn around the marks for everyone, then we have to turn around the marks for no one. Because we can't give some people their feedback and other people not get their feedback, and then people go into the final exam without the same amount of knowledge of how they've gone so far. So it has to be fair, which means that the second assignment marks have to come back after the exam. This is just because our exam is very, very early when you think about it. It's the Saturday before the exam period starts, technically. I mean, I guess technically the exam period starts on... There are some exams on the Friday of week 11, but ours is on the Saturday. So it's even like, if we consider the exam period to start on Monday of week 12, then our exam is like a pre-exam that happens even before that. But I think the exam period, technically starts on the Friday nowadays. But either way, we can't turn around the marking in that number of days. Yeah.
Yep. To Cameron's point, if I may make a point there quickly, I wish that I could have somebody tell me when I'm writing something how many bugs are going to be in it, because it would make it very easy for me to like go and find them. Unfortunately, there's no way that we can tell you that. Like, I mean, it depends how you count bugs, and equally, even if we could tell it to you, I'm not sure that we would. Maybe we would.
I mean, we could give a number of things, and then within 24 hours we'd have a student saying, "Oh, here's one you forgot," and we'd be like, "Oh, that's true. That's interesting. We didn't think of that one, So yeah. So I think
the fear of my life.
I can tell you there are exactly 30 interactions that we have planned into the reference solution that you will not be expecting. And then by the time I finish saying that, I'll say, "Oh, actually 31, because I just thought of another one." And a student just asked a very, very good question on the forums, so let's make that 32, and it'll snowball like that. So we'll never be able to sort of lock down and say this is the exact number of ways in which we'll try to trick you, because we'll do some inadvertently, I think, while we're doing things.
Known unknowns and unknown unknowns.
yeah. So it's not even like Cameron's asking, is like, would you be allowed? It's even worse than would you be allowed. It's like, do you even know? It's like, have you written code for this assignment that you know exactly everything students could do with this, and you know all of the particular traps and pitfalls around what you've written? And the answer is no. A lot of people think that us who run these university subjects know so much about the subject material that we would never be caught out about things. But I don't know. I'm pretty sure you've been to my lectures, right?
Imagine what that would be like.
There's a reason why "he's behind you" is a meme in the lectures, because I make mistakes as well. And there's often a lot of things where it's like, I actually don't know the answer to that question. So we're going to have to put that into code and find out, or we're going to have to Google it and find out. And I actually think that that's a better attitude to have overall, which is the idea that never expecting 100% knowledge, never expecting 100% capability, but learning about gaining more capability from the gaps in your knowledge, which is, I think, much more interesting, because all through your career, everything that you learn is going to be based on you having a gap in your knowledge somewhere and going, oh, I want to know more about this. And then you'll end up further than where you were before. And so it's more of the attitude of like, let's assume that we don't know everything and assume that we will have to learn things and then go on that journey. Yeah.
Expect the unexpected.
Yeah. Okay, so let's go back to...
I'm also just about to drop out for 1 sec, Mark. I will
yeah.
be right back as my internet dies.
Oh, it's that? You have to drop out for a sec?
I'm about to drop out.
Okay. Oh! That's great. Oh, you had to come back in with your phone? That's all right. We can still see you.
I did have to come back in my phone. Yeah, sorry about that one.
That's all right. I mean, at least we had you for a little while on your good internet for you to talk about the extension stuff. That was the plan. You're getting Tom in here to talk about the extension stuff. Okay, so on from that, assessment and marks, because I think everyone's always going to be like, yes, we would love to learn amazing things from what you're teaching us, Mark, but we also want to get lots of marks, and we all want to get as high marks as we can in this. So let's look at the assessment section here of the assignment, and people are always wondering about how many marks we get per part of the assignment. So we've actually added, rather than just putting it all right down at the bottom of the assignment specification, we actually put some stuff in the marks here as well. We did not put exact numbers in these stage marks because exact numbers assume that you've got everything correct and your style is perfect. So we're not talking about maximum numbers here, but we're talking about reasonably achievable numbers. So if you've gotten stage 1 working and you have a reasonably clean style on your assignment, you're probably going to get a pass mark for the assignment quite easily. So I just think mean quite easily. That doesn't mean that it's easy. It's still work. You still need a working understanding of linked lists to do this. So that's what we're saying is the bar that we've set that people must be able to reach is you've got the ability to add to linked lists in a way that I haven't taught you, but I've taught you other ways of doing it, so you could modify my code in some way to get there. And you have the capability to loop through a linked list and check for a certain condition. And that is something that I've taught you, but not in exactly the same way. It's always going to be like that, right? I teach you the concepts, but I'm not going to give you copy-paste code to pass the assignment. I want you to show you've understood it. So completing stage 1 with good style is going to get you a pass mark. And as I was saying before, stage 2 is going to push you to a credit. Stage 3 is going to push you to a distinction. And then the extension is for those people who are going for shooting for the moon, in a sense, trying to get maximum marks and stuff like that. The extension will be if you're trying to push beyond the what we consider as the actual useful capabilities you need to learn are in the first 3 stages, and the extension stuff is like, this is interesting, but not necessary. Question there from Leon. Let's just say you don't get to fully finish the assignment. Could you possibly still get full marks on style? So if we look at the style marks, 15% of the core marks is based on style. If you only complete stages 1 and 2, you can still get the full 15% here on style. So you don't need... it's not like 5% style for stage 1, 5% style for stage 2, 5% for stage 3. We look at all the code that you have written, and then we give you a style mark based on that. So, I mean, I'm thinking like the worst and dodgiest way to do this is you hand in a completely unedited beats.c and you get decent style marks for it because all the style in here is ours. You're still not going to get full style marks for that because we're going to look at that and your tutor's going to hand mark this, look at it and go, you didn't write anything, so I can't necessarily give you marks for style. But
sorry.
If you write a small amount and it all kind of still fits with the style that we have here, you can still get quite a few marks for that. Sorry, Tom, were you just saying something there?
No, I don't think so.
Right. Cool. So the style marks are not attached to completion of stages. They're an overall look at everything that you submit. I mean, submit some code. I mean, technically, there are no style issues in an empty file, but that doesn't mean that you're going to get the full style marks in an empty file.
I just have this image of like Mark grinning, being like, "Well, there's no style issues. You can't take.
There's no style issues, but it's not like you have 15% and you remove marks for style issues. It's like you gain style marks for showing that you know how to write well-written code. But the short answer to your question is yes, you don't have to fully finish the assignment to get full style marks.
Yep.
So yeah, the core is worth roughly 80% of the total marks. Yes, Anders just said there are no header comments in the empty file. So if you run 1511 style on an empty file, it will tell you that you haven't properly credited that file to yourself because you haven't put your ZID in it. It'll tell you that there's no header comment. But it won't tell you that there are indentation issues or white space issues or anything like that. But in order to get marks for proper indentation, you have to have actually done some indentation, so you can think of it like that. But you don't have to say, like, if you've got stage 1 and stage 2 working, the point at which you started struggling was stage 3. So plenty of people are going to start struggling at different points. So if you know that you start struggling at stage 3, the deadline's coming up, what you might want to do is say, all right, I think there are more marks in the style. I'm going to just do a quick style review of everything that I've done in stages 1 and 2, all the stuff that I know is working, and say, how do I make this as readable as I can be? And then I've got that. And then if only after that, if there's still time for the deadline, may I go back to stage 3 or something like that. Yeah. So that's what I suggest. I mean, usually my suggestion is you've written good style from the very beginning, which is why you got as far as you got in the assignment, because the better your style is from the beginning, the easier it is for you to debug your own code. Okay, so we have roughly here the marks breakdown. It's not really super detailed, everything in here, but you can, I think, wait for your marks for assignment 1 before you do a style review of your assignment 2. Your tutors, if you didn't get full style marks, and who's getting full style marks? Like, there's only going to be like sort of 5-10% of the course that are going to get 100% style marks in their very first assignment when they don't know much yet. But the feedback you get from assignment 1 should push you to higher style marks in assignment 2, because there'll be plenty of feedback in assignment 1 from your tutors saying, okay, there's an issue here, and this is something that is going to make your code a little bit more difficult to understand. So you go, oh, okay, let me change that for assignment 2, and then you may find even that your debugging in assignment 2 is easier based on the advice you've gotten about assignment 1. Style marks, extension marks. Tom, did you want to say anything about extension marks?
No, apart from this, they'll be pretty much the same as what they were for assignment 1, with the proviso about that 5% thing, which will be very clearly indicated in the spec. But the spec will just say everything it needs to say by the time it's released.
Yeah. So, not much to talk about that yet, I'd say.
There shouldn't be.
Yeah. That is actually everything that we'd prepared to talk to you about.
There is one other thing.
Oh, yeah.
Which I hesitate to bring up because, unfortunately, it's not. I've been told that there was a bug in it this morning, which I still haven't entirely fixed. But CS Beats has a synthesizer.
Ah, yes.
Which is a program that will take in the output from your CS Beats, from printing CS Beats, and will turn it into music. So one of the things that we did, and we'll probably still have this year, is you can create your own music, and you can actually upload it so it's visible online, so you can share those links with your friends. There's no plagiarism concerns if you're sending your friend music that you've made, because you can't reverse engineer what algorithm you use to do it. Copyright concerns, perhaps. I don't have.
I don't think so. I think a reperformance of copyrighted music is not, like, because we're reperforming it in a completely different format. So if you want to do just like the Mario theme tune on a set of like 10-foot tall Tesla coils, you can do that and put it on YouTube. I've seen it. If you want to rickroll the class, if you can figure out the tune to that and be able to program that into CS Beats, you can do that.
Yep. So that's a challenge. It's not worth any marks, obviously. Well, obviously it won't be worth any marks, but certainly it will be worth MARC, as in marks.
Or mark coins. It'll be what
Mark
you can
coin.
sell. You can sell the NFTs of your musical creations for mark coins. None of those
Yep.
have any value. In fact, the NFTs will have negative value because you actually have to mine the NFT, and you could have, with the same process, been mining Bitcoin instead, but you won't get anything out of the NFT, so it's actually negative value. So don't try to sell it; it won't work.
At any rate,
Yeah.
God,
Cameron
welcome
asked,
to cryptocurrencies.
Have we been satisfied with the marks for assignment 1 so far? Is this particular cohort doing well? First off, I will never be comparing cohorts against other cohorts, other than a slow growth over decades in the capability of students. So then I might do a trend saying that yes, students 1 decade on had more programming capability coming out of high school or something like that, or but like even then I would never say that they picked things up faster than people years ago, because humans are still humans. Also, no, we don't. I haven't actually looked at them yet because I'm not going to look at the raw marks, because the raw marks are just the auto marking program, and I don't trust the auto marking program as much as I trust my tutors. Tutors are students as well, but after the tutors have looked at it, then I'll look at the assignments, and I'm probably going to say something along the lines of I'm very, very happy with how people went, because it's very rare for me to look at assignment results and say I'm unhappy with the students. I don't think I'd ever say that. If all the assignment marks were really bad, then Tom and I would have an emergency meeting, and we would say we have made a grave mistake with how hard we made this. Because what we were supposed to be doing is getting a good distribution of marks from students based on how well we design the assessment. The assessment has to be related to what we taught, and it has to expand on what we taught in a particular way for it to work. So we will do that analysis, but it's very unlikely that I would come back in week 9's lecture and say, I'm very disappointed in this class for their inability to do such and such in the assignment, because what I learnt this from my Kung Fu teacher. It was really funny because he was teaching some kids Kung Fu, and then the master who taught him came up to him and said to him, they can't punch, they can't kick, and walked away. And that was it. It was so funny because what he was saying to my master was that you haven't taught them properly how to punch, you haven't taught them how to kick. He didn't say anything to the students because it's not their fault. So if there is any kind of disappointment there, it must be disappointment in myself. Or if I want to, I can have disappointment in my tutors. I can say, you haven't been teaching this properly. But it's never going to be, it's the student's fault, because you're following what we're asking you to do. You're listening to our lectures, you're going to your tutorials and labs. I'm assuming that that's happening. If that isn't happening, that's your issue. But
even then, if you're not going to tutes and labs, that's still on us. To some extent,
but that means we're making them
know,
so boring that people don't want to go, right?
We should try and avoid making them that boring, but
Yeah, so it always comes back, right? So it always comes back to say that a student is never at fault if a teacher is at fault. So if you're missing something, it's usually our fault.
There's a whole rant I could go on about no fault reviews and this sort of thing. But this is sort of idea of like assigning fault to people is both a bad idea and also just not true, because it's just like people aren't. It's not like any of you are not trying to do the right thing. I'm presuming. I'm hoping nobody here came into UNSW being like, you know what I'm going to do? I'm going to cheat the system. I'm really going to like just try and mess with Mark. Like that's not what happens.
Yeah.
So.
Okay, so what were people saying? As Alex was saying about a normal distribution. It's actually quite funny because 1511 has nothing like a normal distribution. I would say that later courses might end up with more of the normal distribution in mathematical terms is like that kind of bell curve. 1511's nearly flat because you get this, that you do have a bell curve in terms of like how much people learn from the course, but then at the top end you've got this weird thing of people who have done a whole lot of programming before. And then you also even get this thing at the bottom end because this is a first course. So, I mean, I really don't want to say this too much, but there's some people who are going to do this course and say, thanks, Mark, that was lovely, but I don't think I want to continue with computer science. It's like, that's fine, you know. People have got other things they might want to do with their lives. So it actually ends up really flat.
I mean, alternatively, they might...
Yeah.
Hopefully it doesn't happen, but...
Yeah. I mean, that can happen as well. So, Leon was asking about past exam questions that you can practice on for the finals. So, I don't know if you've been noticing the revision tests that we've been releasing each week. They've been topic specific, so they're usually on the topic that was was learnt about in the previous week in the labs. I would say, what do you reckon, Tom? About 50% of those are past exam questions?
I'm not
or
sure
more,
I'd go
or
that
less.
high.
I don't know. But even it doesn't matter even if they were or weren't past exam questions. They're written in the exam question format. So
and
I would say that is the bank of questions to look at. If you want to calibrate the difficulty of different questions in the exam, just wait, because we're going to talk about the exam in week 10. But there's also the majority of the content in week 10 is also going to say this is calibrated to the level of a question such and such in the exam. Your exam is also going to be built really similarly to everything else we've done so far. So your labs and your assignments and stuff are all set up with this escalating difficulty thing. So you'll notice that, like, we don't say stage numbers in labs, but you can see them. If you do the stuff, you can be like, oh, the first question was copy paste what Mark did in the lecture. Why is it so easy? And it's like, well, it's the basic concept, right? So if you can do that, then that's okay. If you can notice that it's a copy paste from that lecture, it means you're paying attention, and that's that level. But then the last question might be like, I cannot even think about how to do this. I do understand that it is in the same topic field that we've been talking about, but I can't see the link to get there. And in between is all the other stages of difficulty. So everything that we've done in the course is designed so that you can work until a certain point and say, all right, I'm out. You know, so you work up to a certain point and go, I've learnt a good amount here, and I've pushed myself as hard as I can push, and I know that I don't need to go on to these next questions because I know they're going to keep getting harder. So you can reach your point of, like, finish, or your point of even frustration or something like that, and go, okay, we're stopping here. The assignments are the same, the exams are the same. So the exam's going to have explicit difficulty curve increasing, so you can choose where you get off the bus, basically.
Yep.
Yeah.
It's worth noting that in week 10 you will see at least 2 question 1s, 2 question 2s, 2 question 4s, a question 8, a bunch of multiple choice questions, and we'll have references. There's also like a list of basically like, here are some other questions that you've seen in labs and tests that are equivalent or sort of equivalent to these other questions. Yeah. So like there'll be plenty of revision resources.
The final revision test also has things. When we're referring to question numbers, I will tell you what they mean later.
Yes,
because there's a specific number of questions and they have specific... Like, what we're going to do... and again, this will happen in week 10. But what we're going to do is basically give you the entire meta for the exam. So we don't want anyone to have to play the meta for the exam or have to discover the meta during the exam. We give all that to you in advance, and then you just do what you need to do with your actual, like, learnt knowledge from 1511, not have to, like, you know, like some exams is like, it's a game in the exam, and if you don't understand the rules of the game in the exam, you don't understand how to get the maximum marks. What we're trying to do is give you all of that, so all you do is you go in there and try to get maximum marks instead. But we'll do that later. We'll tell you all about it. If anyone doesn't know the concept of meta, it's very much a gaming thing. It's like, there's the rules of the game itself, and then there's the unwritten rules that are the concepts of how a game kind of runs. And if you understand them, you're going to be able to win games more often than you would without understanding them. We don't want your assessment in this course to be governed by a meta, which is why a lot of the times when I talk about assessment and things, I say, here are the easy marks, do these bits first. That's why I keep saying in the assignments, the style marks are worth more than the performance marks. We set it up that way, and I'm happy to tell you that because it's a low effort way to get high marks, because I'm also trying to convince you to write that way. Because one of the things that I've seen, graduate programmers get judged on is their programming style rather than their programming performance. So if they go into a programming interview and they write really bad programming style, the interviewer immediately jots down a little note saying, I don't think that we're going to be able to work with this person's code. And then there'll be an issue there, even if the code's perfect in terms of, well, it's not perfect, but it was functionally perfect, but read badly. There's some issues there. So Cameron's asking, if we can do the 2 assignments well, how much more study is required for the exam? I would say that assignment 1 covers 4 weeks of the course, and assignment 2 covers 7, would you say, Tom, weeks of the course?
8.5 of the
it's
course.
Probably more
depending on where you get up to.
Yeah. Actually, if you go deep in the assignments, sort of 8.5. It's nearly everything in the course, but not quite. The exam is worth 10 weeks of the course. So I would say that going into the exam after assignment 2, I would definitely, even if you were fully confident about how you went in both assignments, it's been months since you last worked with arrays, in a sense, at a deep level. There are some array stuff in the in assignment 2, but it's not nearly at the level it was in assignment 1. So it'd be okay, which things have I forgotten? And which things weren't even tested in the 2 assignments, because the 2 assignments are really based quite strongly on arrays and linked lists. There's some other stuff in there, like when we think about command line arguments, when we think about building our own structs as opposed to just using structs that are already there. What other things? There's little bits here and there that you want to go back and check on. Yeah, Tom, you're about to say something?
The thing I would say is, having done assignment 1 and assignment 2, if you found that the first few stages were relatively solid, I agree with Mark that you should still go and revise, but you're probably not going to find too much in questions 1, 2, 3, and 4 that surprise you, in the early practical questions. Go and revise anyway, because it's a slightly different style, doing smaller problems that are individually a little bit harder as opposed to a larger thing when the part of the difficulty is just keeping it all together. The assignment is, 400 lines of code, whereas most exam solutions would be 20 to 50 to 100, depending on where you are in the exam.
Yeah. The exam's much shorter and sharper, as opposed to an assignment, which is what we consider a weeks-long ongoing project, where you write more code, whereas the assignment is just you write hard code instead.
Yep.
No
the
hard
thing
code,
I would,
but keywords.
The thing I would say is, if you feel comfortable saying, I found the assignment relatively doable, you're the sort of person who should be considering, do I want to try and go for a question 6 or question 7, the later practical questions, which are the harder ones. The assignment will give you some tangential preparation for those questions, but that's the sort of thing where maybe you want to be spending some time thinking about, okay, maybe I want to try that sort of harder problem-solving challenge.
Yeah, that's actually the bit where some of the challenge questions from the labs are more where you're going to find the bits you may want to brush up on if you want to. Leon was asking about you'd heard that previous finals were 24 hours. This one won't be 24 hours. It is definitely longer than it takes to finish. So these exams, when they were run in person, they were 3-hour exams. A 3-hour exam is pretty intense time pressure, and they also didn't allow you to use the internet. So this is actually different, where you can use the internet. Basically, if you want to, you have 2 monitors. If you do a 2-monitor setup, one monitor is just my lecture notes, and the other monitor is your working code and stuff like that, and you can be I'm just going to go back and forth. You won't necessarily have enough time to rewatch all of the lectures during the exam, but you could watch some snippets if you needed to. So it's sort of open book in that regard. It's not fully open. You can't just hop on a forum like Stack Overflow, copy paste the exam question in there and ask someone else to answer it for you. People in Stack Overflow are also pretty they know when a student's trying to cheat on stuff like that, and you may end up getting banned or something like that for that kind of thing, or
in
at
addition
least
to the fact that
downvoted
I'm an avid Stack Overflow user, and I do keep an eye on the C questions
Yeah.
So,
So
like,
what it is basically, I mean, we are going to talk all about this in week 10, but I mean, while you're asking, we've got time, happy to answer. So it's basically like open book, but you can't ask the internet to do anything for you after the exam started. You can look up references that already exist beforehand, that kind of thing. And also it's an afternoon exam rather than a 24 hours kind of thing. So if you're in Sydney, it's going to be afternoon. We haven't fixed the time in place yet. We haven't actually done our full calculations on daylight savings versus time zones in other countries, because the reason why it's longer is we can't provide tech support during the exam. So if your computer has an issue, we can't go to your house and fix your computer, as opposed to because when the exam is here at CSC, when I say here, this isn't CSC, this is my house, but
when it's here.
Yeah, when it's where Tom is, we literally have system support on call, and they will come in and fix computers that people are doing exams on at the time, So the delay is momentary at most. Whereas if you have a problem at home, then it could take you like an hour to fix something or to get another computer set up and ready to go or something like that. And so that's why the exam is usually twice as long as it would actually take you to do it. So it's a 6-hour exam, not a 3-hour exam. But anyway, this is all stuff that I'm going to talk about when we talk about the exam itself. And Cameron was saying there that you found the extensions for assignment 1 easier than some of the challenge exercises. That is true. Some of the challenge exercises are a big ask. Although I have seen that some people have actually submitted potential solutions for the substitution. Crack substitution cipher. Yeah, we've got an interesting email that I'll talk about later. Someone managed to uncover some issues with DCC in their crack substitution thing.
I've been meaning to look at
I found that very interesting. I probably should say that in the lecture, because I doubt that person's going to be here, because there's not that many people here right now. But we're gonna look into that, because I think that's really interesting. May have uncovered ways of using code that DCC is not familiar with, because DCC is really made for people who are learning code for the first time. But whoever
I have
did
half
this,
an email written about that. But
oh yeah, you've been analyzing it already. I know it's there, but I haven't done any analysis on it yet.
I haven't done anything about it apart from write the email that I'm going to send to. We'll talk about it later. But we're investigating it. Yes.
Yeah. So it's interesting things, and I think it's always interesting seeing, I think the greatest thing that you can do as a student is ask us questions that we don't immediately know the answer to. So I think something like this is always really interesting. And you would have seen that in the lectures. I've been receiving lots of questions from people like, what happens if you do this? And I'm like, you know what? I have not done that in years, so I can't remember. So let's either we try it or I bounce it back and go, why don't you try it? Because I have to talk about something else right now and stuff. And I always find those super, super interesting, because that's learning,
I mean, genuinely,
sorry, you.
I was going to say, in my tutorial today, there's something I learned that I'd forgotten that existed and I hadn't used in years. And I say this at the start of all my terms, we're all learning, and I always learn something new every time we do this course, even though I've done this course 8 times now, I think. I always learn something really interesting, and it makes me so excited.
Yeah. Okay. So I think that we have wrapped up questions about the assignment now, especially because the last 20 minutes or so were questions about the exam, which we will be covering again. So I don't want this live stream to be a reference for the exam. So basically everything that was said about the exam today, we're going to repeat it in an official lecture so that everyone can see and everyone gets those answers. But those details will be coming later, but we might wrap it up here, because I think we've talked enough about the assignment so that people can get started with it and have a decent understanding about how they're going to approach it. The other thing I'm going to remind everyone is that I've spent, by the time we get to the end of tomorrow's lecture, I will have spent 6 hours of the lectures, which is a lot compared to any other topic on linked lists, and there'll be one really big code example that does lots of different things. And if you're struggling with the assignment or you're unsure about anything in the assignment, that is a really good piece of reference code to use, because it's building it up bit by bit, lecture by lecture, different capabilities and things. So hopefully that will be a nice jumping point for you to like take my code and modify it for your assignment. Okay, so we'll wrap it up there. Thank you very much for coming along, Tom.
Thank
Thanks
you very
everyone.
much for having me.
Oh, sorry, Tom.
Thank you everyone for coming along.
Yeah. Yeah, and thanks everyone for coming along. Hopefully that was helpful for the assignment. Good luck with everything. Obviously, things like help sessions are going to start ramping up again for the assignment. Forums also, forum response time will start ramping up for the assignment as well. So, and obviously you can talk to your tutor in your tutorials as well. All right.
Yep.
See you later. Thank you, everybody.